So, hi everyone. My name is Anjeet Kumar, and I am from Maximus. So today I will be teaching how we can solve ordinary differential equation using MATLAB. So as we all know about ordinary differential equation, we solved in our college semesters. So we can solve it using MATLAB also. So MATLAB have the that particular function so that we can solve using Rangekutta. I will tell later about this. So those who are not familiar with MATLAB, so I will be providing link how to download MATLAB, and then yeah, you can download it from there, and then you can log in using your webmail ID. So this link you can follow, and then you can download it, and then you can log in through institute webmail ID, and then you can proceed it. So our institute have purchased license already, so you can use it. Yeah. Yeah, so here we can see about this. This is the code snippet written how we can like how to write. I will tell later like how we can use it to solve any equation. So let's suppose any equation is there y dash is equal to 2t. So this is one type of ordinary differential equation. So this is ODE where y dash will be written as dy by dt and it will be 2t. So we can like now we can easily solve, like I'll say like dy is equal to 2t dt, and then we can integrate dy and then 2t dt, or then we have to put the condition like what will be our initial and what will be our final condition. So this will be t naught and this will be tf, and this will be y naught, this will be yf. Yeah, so we have to put the initial condition also. So that's what we write in code also. So see how we can so this is the snippet of the code. So how we wrote it, we wrote it like t and y. So here we wrote what are all the variables involved. So here variables, what are the all the variables involved, y and t. So that's what we write, t y, then OD45. This 4 5 have the significance. This 4 5 indicates Rangekutta 4 5 order. So see, you can see here Rangekutta 4 5 formula. So as we all read in the semester, if you don't know then also it's okay. Yeah, so Rangekutta is a method through which we can solve any OD. So yeah, so this MATLAB use this Rangekutta formula. So you can see here OD45 OD function. Here we have to write about OD function is what, 2t. Okay, so we'll write y dash is equal to 2t. So OD function is 2t. Always you have to write like this. So dy by dx will be on this side, and then whatever function will be there will be on another side. So we have to write like this OD function. So here we'll write t and y. These are all the variables involved here. Then we'll write OD45, and then OD function will be what, 2t, and then t span. T span, let's suppose t naught, our t naught will be 0 and t final will be 5. So we'll be writing 0 to 5, and here we have to write initial condition. What were the initial condition for y? So let's suppose, let me erase it. Yeah, so let's suppose this OD represents some trajectory. So let's suppose y is that representation of distance and t is time. So y varies with time. So one function is there that is connecting y and t. So we can say at t is equal to 0, what were our initial condition? What was the y naught? So we can say like this. Let's suppose that t is equal to 0, y naught was 0. So in place of y naught we can put 0. So that's how we write this snippet of code. So this code will be important. I will be telling like how we can solve it, how we can put it on our MATLAB. So just understand it now, like how it is written. So all those variable who are involved in this equation, so we'll be writing like this t and y. So t and y are involved in this equation, so we'll writing t and y, then OD45. So on the right hand side 2t is there. We have to always write our equation like this, then only this OD45 solves. So to put a single order differential in this side, and then whatever function that are left, we have to put it on another side. So yeah, we will see examples and then we'll understand more in this. So we'll be writing right hand side here only 2t, and then initial condition for t is 0 to 5, and then our y naught will be 0. So this is the snippet of code. I will tell how we'll write the full code. So we can see each row in the solution array. So is telling each row in the solution array y correspond to a value returned in the column vector t. So for a column vector t means 0, 1, 2, 3, 4, 5. For every value, this code will calculate y for every value. So it is like that 1, 2, 3, 4, 5. For every value, this will integrate and then will calculate the value of y. So let's suppose you have done a indefinite integral of this dy by dt. So you will write like y dash is equal to 2t. So dy will be 2t dt. So it will be t square by 2. So let's suppose it is like t square plus c1, some constant, and then y. So now this code have calculated c1 value, and then for every t value, this will give the value of y. So it is telling like this: each row in the solution array y corresponds to a value returned in the column vector t. So okay, so I think everyone have understood this one. Okay, so we'll be proceeding further. Yeah, so it's written about all MATLAB ODE solver can solve a system of equation in the form of y dash is equal to ty. So that's what I said. Like single order differential will be on left hand side, and whatever function that will be left. Let's suppose y dash is equal to 2t y dash plus y ty 2t plus 3. So we will be putting y dash this side and all those in the other side, and we'll be writing this in the this in place of this ODE function. So that's what it is written in form of y dash is equal to ty. So all problems that involve a mass matrix, yeah. So mass matrix I will tell later what is this mass matrix. So we'll be writing like this only: y dash is equal to f of ty, or a problems that involve a mass matrix. I will tell later what is mass matrix. Specify the mass matrix with mass option ODC. So I'll be telling what is uh, and this line is showing about there are other functions also OD23 and 15 that will give you better result than this problem if you want high accuracy. So for different types of problem, for different types of real problems, we use this type of function. Let's suppose we want more accuracy. Let's suppose there is one chemical reaction that have some OD, so that needs very fine values of y with respect to t. So there we need high accuracy. So we'll be using OD23 and 15. So these are all also available. So today we'll be learning about OD45. So this also gives the better result only, but with the accuracy. But OD2315 will be giving high accuracy. Okay. Okay. So this is telling about uh, option. This one more snippet is there, options. So in example we'll be learning how what is this option. Just in this PPT, just learn about what is written on this. So option is like defining a mass matrix. So I didn't told you about mass matrix, right? So okay, we'll be going to another slide. So I'll be telling you later, don't worry. Okay. Hmm. So let's suppose this is the example. As I discussed this example earlier also. So single solution component must component two opponent. So solve the OD. This is written y dash is equal to 2t. Okay. So this is our question. Specify a time interval between 0 to 5 and the initial condition as 0. Means at t is equal to 0, the y naught will be value of 0. Okay. So only if you will do indefinite integral, you can see like you are getting only one constant. So one constant value you can find out through this value. So that's why they are asking for initial condition. So see how we wrote it. We wrote first we defined t span 0 to 5. You can directly put here also t span in place of this. you can write, I will tell you later. I will tell you right now only. This y naught will be 0. So see, we can write it like this also, ty. So these are the two variables involved. Then OD45. Then at the rate ty, means this function is made up of two variables, t and y. Like it can be there, like you can see two t is there. There is no involvement of y, but you can think about like this, 0 into y. So you should always write like this. So whatever all the variables involved, we have to write at the rate ty. So 2t is our function. So I told you na, right hand side. So 2t is our function, and then t span. So you can write like ty 2t, and in place of t span you can write like this, and then you can write like this. So in one code only you can solve. So what it will give you, it will give you some time gap, t0 1 t2 t, and then it will give you like this. So two column vectors it will give you, one will show time and one will show y value, corresponding y values. So output of this will be two column vectors. So in one column vector it will be showing t is equal to 0 1 2 3 4 5 like that, and whatever the corresponding value of y of this, like after solving this equation, we'll get one function. So whatever value will be there, it will be showing you. So now you can plot also, and in the plot you can see. So in the plot you can see how this is showing about this graph has been made. So corresponding value of t, we got the corresponding value of y. So for a particular value of t, we got the particular value of y. So this is the output of this equation. So we got t, we got y, so that's why we have shown this is the mark to represent like this 0, yeah. So I think everyone have understood. This is only plotting. We'll tell like in like in our upcoming lecture what is the plot function. So I think everyone have understood what it will give the output, how we can provide the input. So output, this snippet of code output will be two column vectors. In one column vector it will be time gaps, t is equal to 1, t is equal to 2, like that. You can change the gap also. In this one you can write like 0 5, and let's suppose 0.1. So it will go like 0 0.1 0.2 0.3, like that it will go. And for that particular t value it will show the corresponding value of y. So this will be the output of this snippet of code if we'll write in MATLAB. So yeah, understood. Understood this one. Okay, so yeah, yeah. So this is one of the equation. So you'll think it's this is second order ODE, means second order differential is used for making this y double dash. It means d square y by dx square. So you can say like this equation is like this: d square y by dx square minus mu 1 minus y square dy by dx. So now this is the like tough type of equation. So this also, this OD can solve very easily. This OD45 can solve very easily. So I told you what you have to write like this. In the left hand side you have to write like y dash of form and something here, so that you can put this something here in place of OD function. So here two ordinary differential equation like 2 degree is applied, like two order differential equation has been used. So how we can solve this? We have to write like this only, but we have to write this equation. So how we can? So we can like we can bypass it using like defining a dummy variable. So as I told, if not given a single differential, means double order differential is involved here na. So then try to introduce a dummy variable. So we will let's suppose we will assign dy by dx as some variable y1. So what will be y1 dash? So y1 dash will be d square y by dx square. So have you all understood like how I wrote this? Y1 dash is equal to d square by dx square, and this y1 is dy by dx. So I have assigned dy by dx as y1, a new variable, and then we can write it as a single. Otherwise I have to write like y double dash. So we don't have to write like y double dash. So in ODE45 you have to write like this only, one single dash only. So I have introduced one variable y1, and then dy square over dx square will be written as y1 dash. So here also you can see how we have solved it. So I will be telling you. So see, this y dash is equal to y2. So this equation is there na, y1 double dash. So we have assumed like y1 dash is equal to y2, means this all the differential equation involving y1. Okay, so we wrote like dy by dx is equal to some variable we assigned as y2, and then we can write it like y2 dash. So in the second we will put our all our equation in the form of what? So we have to show also like whatever we assigned it. So we assigned y1 dash is equal to y2, y1 dash is equal to y2, and then in the second line we wrote our full differential equation in the form of y2. So we write like y2 dash mu 1 minus y1 square, or in place of y1 dash we'll put y2 minus y1, and here we have to show also in the first code you have to write also whatever you have assigned. So y1 dash is equal to y2. So here we bypass this double differential, right? Like we introduce the dummy variable and then we can solve it. So yeah, so this way you have to solve the double differential. Yeah. So in this particular slide, we will learn about like how we can use function. So this is very important part to define a function. It is very important part for solving ODE. So as in the previous slide, I have shown you in this particular type we can write like we can introduce a dummy variable. I introduce your dummy variable concept, right? So double differential you can solve using this. So that particular thing we have to write it like a function. So that's why this is very important while using double differential. So this is not important in the single type, like in the single differential ODE, single order ODE. This is not important defining a function and all. But if you are going to solve double order differential equation, then this function is this defining function and all is useful. So you have to firstly define a function and then we have to solve it like this. We have to write it as snippet like this. So yeah, we have to define a function and then we have to write a snippet like this. So okay, so now we'll be learning about like how we can define a function. First we have to define a function in the MATLAB. So this is function, and then dy dt is you can see used to define a function. So this particular name is used to define a function. It is not like you can write anything here. You can write your name also like Anjeet. Like I can write my name also like Anjeet here. It's not like don't misunderstood with dy by dt and all. So this is just used in the, so that's why like it's not dy by dt. You can use any name here. So this is VDP1. So what is VDP1? Now I'm telling you how you can define a function. So then we'll be telling you how we can use this as snippet, and then you can solve the double order differential. So I will be telling every part of this particular definition. So function you will write, and then you will write any name, and then VDP1. So VDP1 will be this name, particular VDP1. Here also you can write any name. So this particular name will be used to call that function. So let's suppose I have to call this function. So uh, I can give you one example. So function is uh, let's suppose for a particular person I have marked one name. So something is Vikram. So I marked name and I have to call him. So let's suppose Vikram do something. Let's suppose Vikram know how to fix mobile. So in my code, let's suppose I have to fix mobile. So I have to call. So that particular name is Vikram. So I will call Vikram like that. So VDP1, here VDP1 will be used to call this function, and this function will do whatever is written in this particular function snippet. So it is like that, and this particular thing will be used to call. And then what are all the variables involved? So t and y are involved. So that's why it's written like t and y. Okay. So here I wrote also VDP1 is name of function, ty input to the function, dy by dt used to define a function. Yeah, so this dy by dt have a use in this particular function snippet only, and if we have to call this whole function snippet, so we have to use vdp1. So here you can see also we have called it like vdp1, we wrote vdp1. So this particular name is used to define. So there are two names, that's why I have said you single by single. So this particular used in inside the function to define anything. So here uh, we are defining a matrix, that is this matrix. I will be writing y2 1 minus y1 square into y2 minus y1. So this matrix we are writing in this form. So MATLAB is what, like in the definition also you can see MATLAB is matrix laboratory. So all the things works here in a matrix form only. So that's why we are writing it in a matrix form. So we are in this function, we are defining a one column vector. So dy by dt is one column vector. So this, so now you I told you one example, na? Vikram example. So Vikram knows to fix mobile. So this function this function have this particular column vector. So whenever I will call this function, na, so this function will give that column vector whenever I will call. So that is there. So in this inside the function we have defined a column vector dy by dt, name dy by dt. So this name will be used to define, and then this name will be used to call. Okay. So yeah. So vdp1. So now we have defined one column vector. So now we are writing our snippet. So t and y. So as I have told you earlier, so what was our earlier equation? Our earlier equation involved like double degree, double order differential equation. Na? So what I told you that time, like we introduced one dummy variable like that y2 is equal to y1 dash, like that I told you, na? Wait, y1 dash is equal to y2, and then we have introduced like y2 dash, then we have put like dy by d square y by dx square here, and then all the right hand side terms. So see, so now this equation, let's suppose I have to write in the matrix form. So what I will write? I will write like y1 dash y2 dash is equal to like this. So there I have shown also this, you can see this equation y1 dash y2 dash. So these are the two equation in the matrix form. What I have to write y1 dash y2 dash and this function. So always, so I have defined a function with this particular thing. Not, we don't have to write this. So as I told you, na, this one will be understood by our like always we have to put all our things on the right hand side, and then the left hand side always the differential will be there, and this is understood by the computer also, this MATLAB also. So I have write only this part while defining the function. See, I have wrote y2, then 1 minus y1 square into y2 minus y1 this side, and we don't have to write this one. This one is understood by our MATLAB only. So we wrote like this y1 dash y2 dash, and then yeah. So this one we define this function. So now we are now these two variables are involved, t and y. So here we'll see like y2 and y1. You will be taking like these two other variables are involved. So one is dummy variable and another is y2. So y2 we can say y. So this is the like this is the way we should write. We should not like y1 and all. We should write like t and y only. Uh, yeah, this is the way to write this snippet. So yeah. So here we wrote like ODE45 at the rate VDP1. As I have told you earlier, like in the previous example, we wrote here at the rate T, Y, and then we wrote like 2T. So whatever will be on the RHS side, we wrote it like that now. We wrote that one only, like 2t we wrote in place of this. So here you can see, that's why I have defined function. Otherwise I have to wrote all these things here. So for like for refraining from this particular part, we have defined a function that is a one column vector, so that we can directly call this at the rate VTP1. It means we wrote this column vector here. So this means that, and then we have defined the T naught TF. This is the T naught, and then this is the TF. And you can think about in the, so this one I told you na 2 and 0. So this one I told you about what initial condition y naught. In place of y naught we wrote like this. Then why it is written like two values. I have told you only y naught is equal to 0 na. So let's suppose we are taking one example, d square y by dx square is equal to 2x. So there is a double degree differential. So there will be two constant involved in this particular differential. If you will like indefinite integral you will do now, you will get x square 2 plus c1x plus c2. So two constants are involved. So it means two initial conditions are also required. So you will think what corresponds to this 2 and what corresponds to this 0. So this 2 corresponds to this particular dummy variable. So let's suppose I know like many have not understood it right now also, so I will be telling. So let's suppose x is there, another function is dx by dt, another function is dx square x by dt. So what will be writing dx by dt? V, this will be writing as a, this will be x. So what we defined as a dummy variable. In a dummy variable we defined v only. See y1 dash. Let's suppose y1 is equal to x. So x dash will be what? V. X dash will be what? V. So these two values are corresponding to that value only. This is the value of this 2 is the value of x, and this 0 is the value of velocity, means v, means dx by dt. So you all understood it, or yeah, I will be repeating it again. Okay. So yeah, I will be repeating it again. Let's complete it right now. Okay. So this is the snippet how we will write it, and then yeah. So this is the snippet how we will write. Yeah. So this is all about plotting this function. So yeah. So now I will be telling you about the output of this function. So output will be what, like it will be giving three columns, 1 2 3. As I've told you, this is double order differential. So double order differential, in one place it will be giving you value of y1, and in the second it will giving you y2, and there is a connection between y1 and y2. Y2 is the differential of y1. I told you na y1 dash is equal to y2. So this is the relation also. So if you want to understand with the real example, so let's suppose x is the distance, so dx by dt is velocity. So this will be x and this will be velocity. So that is here the initial condition also. This initial condition is there now. So this is for distance, means at the date t is equal to 0, what will be the value of x? So let's suppose x is equal to 3 meter, and at the t is equal to 0, what will the velocity of v? V will be 0 meter per second. So this is the real significance of writing like this. So that's why we introduced dummy variable, and dummy variable have the significance. So you can see here we defined y2, right? We assigned to a new variable y2. So y2 is velocity here. Okay. If you are so I am assuming it you have understood this particular thing. Now I will be compiling again, telling you what are all these things. So firstly we define the function so that we don't have to write this again and again. And this column vector, so this function contains what? Column vector, and this is named to call. This VDP1 is named to call. Whenever I have to call a column vector, then I have to write VDP1. And whenever I have to define anything inside the function, then we will use this name, dy by dt. So that's why inside the function we are defining dy by dt, and in this function we define a column vector y2, and why we are defining this column vector. So as I have told you, you have to write like in this form. So this equation, these two equations were there in previous. So as I have told you earlier also. So we'll write like this, y1 dash y2 dash and then y2 y2. So we have to write this particular column vector only. So we wrote like this, and then we are writing our snippet ty. So you have to write like this only always. So ty ODE45 at the rate VDP1, we call this column vector. So as I told you, like 2t we use there, so it is like that only. And this is t naught tf, means initial condition, final condition. And then this is, as I have told you earlier also, this is what, this is this is for new dummy variable introduced. So if we'll say like x, so another will be dx by dt. So this is the condition for, this is the condition for x, and this is the condition for velocity dx by dt. And then, so what will be the output of this? So output of this will be 2 3, means 3 column will be there, 3 column. So in the first column it will be writing like t is equal to 0, t is equal to 1, t is equal to 2 till t is equal to 20. Okay. So in the second column it will be like x, and then the third column it will be like v. So as I've told you, you can see here, from here. So this is our initial condition. So t was 0 and the final condition t is equal to 20. So initial condition was 2 0. It means that t is equal to 0, x is equal to 0, and v will be 2. And then it will be and then this code will run, and then this code will fill all this value till t is equal to 20. Now we got this value. So this is the plot function. So now we use the plot function. How we can use this plot function ty1. So here we have put taken one column, and then we plotted it with respect to t. And then here we will you use the second column, and second column with respect to t we use, and then we plotted both the function, and then we got this particular. So now now I've told you about like how we can solve the double differential equation. So it's very easy. So I will be repeating again. So this is the last time. So firstly we define the function, then dy by dt, then vdp1 for calling, and then we will define the our this side, this RHS side column vector. What will be there? We'll be defining it here so that we don't have to write it much here. So ty ODE45 at the rate VDP1. So it means like this is written like here. And t naught, this is tf, this 20. Okay. So yeah, so this is 0, this is 20, and this is the condition for x, and this is the condition for velocity. So t is equal to 0, one column is for x and one column is for velocity, and this all snippet written for the plot function. Okay. So that's all about this, how to solve. So here also you can see how we can write this. So let's suppose this is one differential equation a b t y. So here a and b are constant, some constant values are there, a and b. So see, this is the double differential question. So here we introduce a one dummy variable. What is that dummy variable? Y2. So you can understand with this velocity and this example. So x is distance, dx by dt is velocity, and a will be d square x by dt square. So you can understand like we have introduced a dummy variable v, like that. So dx by dt is equal to v. It means dx by dt is equal to v, like that. So introduce one dummy variable. So yeah, so you have to put the initial condition for dummy variable also. So as I've told you, na, t is equal to 0, x is equal to 0, and v is equal to 2, like that. So and then this code will run, and then this will give you 3 column. This will give you 2 column only. This will give you 2 column, but the third column you have to assume, like you have to know this. Just if we'll write like t is equal to 0 to 20, then you have to assume it like first one is 0, the second one is 1, 2, 3, 4, 5. You will put some gap. So let's suppose 0.1. So it will go like 0, 0.1, 0.2, like that. It will go till 20. It will show all the values, and then your smooth graph will be forming. If you want to more fine graph, so you can use this. Okay. Yeah. Okay. So as I have told you earlier also, this how we can write this function. So function, so this name will be using for definition, and this name is used for calling it. Okay, so these are all the inputs in this particular function. So that's why we have to write like this. So t and y will be input in this, well, while we are writing it, t and y, and a and b. So a and b are also there. So see, you can see here a and b are there. So that's why we wrote as an input here. Yeah, so we defined here, see, we here also we defined what, we defined a column vector. Okay, so here we defined one column vector, that is y2 a by b, this is y2 a by b t into y1. So this column vector we defined, and we have assumed it have written like this only, y dash 1 y dash 2. Okay, so now in the now we come to the our code. So a is equal to 1, b is equal to 2, t span is this one, y naught is 0 and 0.01. So 0 is for what, 0 is for y1, and y2 will be 0.01. This all will be at initial condition, means at t is equal to 0, these values are there. This is dummy variable, and this is uh, this see, I have introduced a dummy variable, but you can think about this x, v and a, distance, velocity, acceleration. So v will be what, dx by dt. So we can say like v is dummy variable to define dx by dt, so like that. So yeah, so see, we wrote here OD5, then we call this OD function t y a b t span y naught, and then this function we have used the plot function. So plot function with respect to t. So what will be the output of this? Output of this will be two column vectors. So sorry for that. I was telling earlier that three column vectors will be given. No, two only. But the third one you have to assume like whatever you have chosen. Here there is a space, default spacing of 1. So it will be choosing 0, 1, 2, 3, 4, 5. And then two columns will be there. One of corresponding of y1 and one corresponding of y2. Where y2 is y1 dash. Okay, so you have to like values will be there. It will be this particular function will be calculating the function, and then it will be finding the values, whatever all the values involving to particular t and all, so will be getting. So if you know the t values and corresponding y1 values, you can plot it. That's why they have plot t, y, and then full column they have taken with respect to 1. Yeah, so they have plotted, so you can get the smooth plot like that. If you'll choose some finer values, see, finer values have not they have not choose, that's why this gaps are there. So you can use 0.5 and then 0.0. So it is like that. Okay, so yeah, so let's up so see, this is one of the function. So here we can see this is the function of t and y function. Okay. So now we will, so yeah, so now we will learn about uh, let's suppose in some question there is a single degree differential is only involved. See, y dash is there only. So y dash is single degree differential equation. But let's suppose I have to make many graphs with the different initial condition. We'll say like I have to check for t is equal to at t is equal to 0. Let's suppose sometimes y will be -4. Then for some condition y is equal to -3, suppose -2, y is equal to -1. So I have to like, let's suppose any problem came where I have to change the initial condition. I have to change the initial condition. Let's suppose the body motion is there. So let's suppose it is 0. Now you have analyzed like at what position it will be at t is equal to 2. So your initial condition will be what, at t is equal to 0, x is equal to 0. Now let's suppose my body is at x is equal to -2. So now initial condition has been changed, right? So at t is equal to 0 will be 2 x is equal to -2, like that. So if there are some problems involved, we have to check it very combinedly. You have to change the initial condition. You have to check for every initial condition. See, for every initial condition, they have made a different graph. See, at t is equal to 0, what is there? For this particular graph, 5 value was there, 4 value is there, 3 value is like that. So see, they have choose many various different initial condition. So I put bodies at -5, -4, 3. Then I've choose like at this particular time, what will be the value? Okay. So this is single order only. This is not double order. This is single order only. And in the single order, we are writing like -5 to 5. Okay. So -5 to 5 means -5 to 5. It will take one spacing only, and then it will assign every initial condition to that particular value. Every initial condition to that particular value. Understood? So that's right. See, in the ODE45, we defined this y prime function like that. So minus 2y 2 cos t. So this is the single order only. So you have to write this RHS side, right? So you have to assume like y dash is, so this is our differential equation, y 2y plus 2 cos of t plus 2 cos of t into sine 2t. So this is our differential equation we have to solve. Okay. So in this condition, we have to change every time. We have to change the initial condition. So this is the thing we have to write. So as I have told you earlier, either you can write all these things here in case instead of y prime, you can write all these things here, or you can define otherwise like y prime is equal to like this, and then you have defined y naught. So see here y naught we have given as a some span. Why not -5 to 5, not a single value? If it will be like only one initial condition, then we will be putting single value, and t span is 0 to 3, so it will be the two values only. So that's why we have put like that. So it will do a calculation for every changing initial condition. So here it is shown for -5, -4, -3, -2, -1, 0. So for everyone they made a graph like this. So I assume it like you have understood about this concept also. Yo, so this one you can try. So this is now we are getting to more tougher part. So this is solve equation of motion for a baton thrown to a air. So I will be not going to how we can see for solving any practical problem. First we have to what we have to do. First we have to define what are all the ordinary differential equation will be there, and then we will be using at last the mathematics to solve that ODE. So first physics is involved to find that equation. So physics is still there only, and then after that all mathematics. So let's suppose baton movement is there. So firstly we will from physics we will get the what will be the ODE differential equation involved. So here I am taking about the maths lecture. So I will not be discussing the physics part. Uh, if the time permits, I will tell like how we can get that equation. Okay. So yeah, I'm going directly to the whatever the from the physics part, whatever the differential equation will come, ordinary differential equation will come, then how we can solve that equation. Okay. So here you can see these are all the three differential equation that are involved in that baton movement. That baton was there, na? So that baton movement was defined using this 3 OD. Now our math part comes. See how we can solve. Okay. So see here many dummy variables are introduced. See q1 is x, q2 is x dash. Okay. So if I have to write x double dash, so I can write q2 dash. So I told you na, like in LHS side you have to write always like one only, single order only. So let's suppose in the differential equation something is written x double dash, then we will write q2 dash. So see x double dash is there now, so here we can write q2 dash, and then we'll put all those other equation, those are not involved in x double dash, we'll put all other equation in the right hand side, and then we'll put we will make a column vector, and we'll define a function, and we'll make a column vector, and we'll put like this all other values. Okay, so yeah, so this is the normal variable and this is the dummy variable. Q2 is equal to x dash, both are connected. Okay, and q3 is equal to y, q4 is equal to y. See, this is the dummy variable, q6 is the dummy variable. So now we have to write all these equations x double dash in form of a single. So what we'll write? Q2 dash. Okay, so q2 dash, and then you can see this theta double dash is written as q6 dash. So you have to write all these equation. Let's suppose somewhere x comes. Okay, so to write all this in a single differential, because we have to make it on the right hand side. All the we have to make it in a single, and then we have to put it in the right hand side. Okay, so that's why we have converted in all in the single only, and then yeah, we have converted. Okay, so we got it. Then yeah, okay, so six equation will be forming, like six equation are there, q1, q2, q3. So we will assume that this will be understand by MATLAB. Okay, so that, like in the previous slide it was showing some six equations, right? So firstly you have to define it also. Q1 dash is equal to q2. I told you in the earlier slides also, I have told you first you have to define, and then in the second one you have to write the differential. So you can write in any order. So you have to write the definition also. See, so if you multiply it 1 with this, so you'll get 1 into q1 dash is equal to q2. So first they have defined it. So you have to make a vector. You have to make a matrix like this, and then this is called mass matrix. Okay, so sometimes we can't divide it like that. So you can see that function, since functions were there, so we can't make it on the other side with this particular q2 dash and all. So in the previous slide you can see there was the equation involving q2 dash and q3 dash both. So in this equation q2 dash and q6 dash, so both were involved in the single equation. So how we can write? So we can write it in the matrix form. Okay, and we can say this is the mass matrix. Okay, and this is our this one I know, like all know what is this. Okay, so I was so this is the new thing to you. So okay, so here I define the mass matrix. So what will be the mass matrix? So I have to make that matrix, so that I don't have to write again and again. And this one I wrote, see this one function I have already told you about, like how we can write this. So this is on the other side, and this is the function of to you have to define the mass matrix also, and we have to put both as an input. So yeah, so you can go to MATLAB and then you can see this example. So this example, as I have gave you basics and gave you advanced concept also, like how it is solved. So you can understand from there also, like in the example how it's written. I'm giving a rough idea, you can check it out there. So this is the mass matrix. So we'll give an input this one also. Okay, so this one and all you can learn how we can define p1 dot m1. So this is also a new concept. So this was very like real life and then very tough example. So I have to tell you about this also, but we are taking a lecture on ODE45. So on another lecture we'll see like what is written like p dot m1 and all this and all. Okay, so yeah, so here comes the last ppt, last slide. So for information about any, let's suppose you will like open this MATLAB now. So your MATLAB will be open, and this particular search documentation, see here. So this is very useful if you want to know about any function. Just you have to type here. So let's suppose I want to know about OD45. So I will write OD45 here and then we'll click search. So full documentation will come with the example. So you can learn from there also. So I gave you basics and advanced concept. Go through that concept again and again, and then go to that pattern example and then learn how they have solved it. So there you will get more understanding. So from my side, this lecture has been completed, and then thank you all for listening this. Yeah, thank you and bye.